Okay, geometry students, we are still in Chapter 1, Section 3, and we're talking about measuring and constructing angles today. So please pause the video, try the warm-up questions, and come back and check your work. Okay, so in question number 1, you were to draw ray AB and ray AC, where A, B, and C are non-collinear. So if you were to draw those, you would have ray AB and ray AC, and of course your rays could be configured differently, but they both begin at this endpoint A, right? And A, B, and C are non-collinear, so the one arrangement that you may not have is a straight line, where A, B, and C are all on a straight line. Otherwise, if you have two rays coming off of an endpoint A, you got it right. Draw opposite rays DE and DF. Once again, we're using the same endpoints. So we have an endpoint D, and we have D going a ray from D to E. This would be looking more like a point. And then a ray from D to F, and in this case, our rays are opposite, so we do have a line. It ends up, we have collinear points, don't we? Solving for x, combine your like terms, and you should have x equals 31, I think. And solving for x in number 4, you should have x equals 4. Okay, so today the vocabulary for 1.3 is here. We're going to talk about angle, vertex, interior of an angle, exterior of an angle, measure, degree, acute angle, right angle, obtuse angle, straight angle, congruent angles, and angle bisector. Most of these terms have been discussed in math prior to this class. So we begin with a postulate, 1-3-1. So from chapter 1, section 3, the first postulate, given line AB and a point O on line AB, all rays that can be drawn from O can be put into a one-to-one correspondence with real numbers from 0 to 180. So we call this the protractor postulate. So imagine we have this line, let's call this line AB, and I'll try to name it here. It's a little hard without my smart board, but we have line AB, and there's some point O on it. Let's just put a point O here. Okay, and if we draw a ray from that point any which way, let's say we draw this way. Okay, so there's a ray. We can find a correspondence from 0 to 180 degrees for that angle that's been formed using a protractor, right? So let's see, oh, I'm moving the wrong thing. I'm trying to move the protractor. Let's see if I can do it this way. There we go. So I put the center of that, this crossbar here, right there, and I could measure the angle from, let's say we make a point out here that's T or something like that. Okay, so from TOB, we can measure that angle starting from ray OB and go up 10, 20, it looks like 26 or 7, right? We could also measure this angle out here, which is AOT or TOA, and we could start from 0 out here and go all the way out to 154, 53, 54, right? So that's the protractor postulate. I bet you can name these types of angles. An angle that measures greater than 0 and less than 90 is good, acute. If an angle measures exactly 90, it is right. If an angle measures greater than 90 and less than 180, we call it obtuse, right? And then what about this interesting angle formed by two opposite rays? kind of love this one. We don't use it as often as the others, but a straight angle, how easy is that? Straight angle. Let's look at postulate 1, chapter 1, section 3, the second postulate. If S is in the interior of angle PQR, so that point is interior of PQR, then, and we have this ray QS coming through, starting at Q and coming through S, then the measure of PQS, shown here in red, that angle, plus the measure of SQR, the blue angle, equals the measure of angle PQR. So PQR is the sum, isn't it, of these two interior angles. And so what operation are we talking about? Angle addition. So a shorter way to write this is angle add, right? Add period post postulate, P-O-S-T period. And there you go. Okay, so now that we've looked at the angle addition postulate, see if you can answer this question. Find the measure of angle YWZ. YWZ. That's what we're looking for. Pause the video and come on back. Okay, so here's the angle we're looking for. We know XWZ. We know the entire big obtuse angle is 121, right? And then we know that XWY in here is 59 degrees, right? So we know that 121, let me see if I can type it out for you. 121 must equal the 59 degrees plus this unknown angle of YWZ. And so let's just call it, well, we can name it what it says, the measure, I don't have an angle symbol, so I'm going to call that, let's just call it X, okay, plus the unknown angle X, okay. So here we have a simple algebraic equation that you simply solve, and hopefully you all agree the missing angle is 62 degrees. Okay, we can make it a little bit trickier, a little more fun if we use algebraic expressions for the value of angles. So Km bisects JKL, and the measure of JKM is 4x plus 6. This little angle in here is 4x plus 6, right here. Okay, and MKL is 7x minus 12. Now, what can we say about these two angles, JKM and MKL? Given that KM is bisecting, this word tells us that the two angles created by the ray KM are congruent, right? So we can set these two expressions equal. We can say that 4x plus 6 must equal 7x minus 12, and solve. And so go ahead and pause, solve, and see what you get. Okay, so we're going to collect our variables to the side with a greater number. Makes things nice and positive. Subtract 4x from both sides, and we end up with 6 equals 3x minus 12. Now we need to isolate x, so let's add 12 to both sides. 18 equals 3x. And when we divide both sides by 3, we get x equals 6. Now, have we answered the question? We've got to always ask ourselves that, right? So find the measure of JKM. JKM, x equals 6. Well, that doesn't equal 6, does it? We're going to have to plug it in, right? So JKM, again, is 4x plus 6. When we plug 6 into that equation, the measure of JKM is 4 times 6 plus 6, giving us 24 plus 6, or the measure of JKM is 30 degrees. Okay, let's try this lesson quiz and come back and check your work when you're done. Okay, if you're back, let's check it out. The angle XTS S is acute. Good. WTU, number 2. WTU is, that's right, it's right. Okay. K is in the interior of angle LMN. Measure of LMK is 52 degrees, and the measure of KMN is 12 degrees. So what is the measure of LMN? Using your angle addition postulate, you simply sum these two angles, right? And you end up with 64 degrees. Good job. Pause the video and try these. All right, for number 4, ray BD bisects ABC. And we have two interior angles, angle ABD and angle DBC. Each of them have an expression given. Because BD bisects this larger angle, ABD is congruent to angle DBC, so we can set them equal. And when we do, we found that y equals 12, but that's not the answer, because the question is, what's the measure of the large angle ABC? So when we plug it in to either one of these, notice we end up with a value of both of these angles being the same, 16, right? And since both of them are 16, the measure of angle ABC must be 32 degrees. Okay. And so this one you'd have to have us check it to make sure you drew a big obtuse angle with a measure of 165. And finally number 6, so WYZ and XYW together form a straight angle, right? XYZ, a straight angle, which has how many degrees? That's right, 180. So we can say that the expression for the measure of angle WYZ plus the measure of angle WYZ was over here, plus WYX, 2x minus 5 plus 3x plus 10 equals 180 degrees. Combine your like terms, 5x plus 5 equals 180. And now let's isolate x. Subtract 5 and divide by 5. And we have x equals 35. Now is that the question? Find the value of x. Yes it is. So x equals 35 and we're done. Yay! Here's your assignment. Have fun!